Hey Rose, second video here. Again, we're doing sum and difference identities. So two things being added up, two angles being added up. So here I have cosine of 5 pi over 12. And of course, 5/12, now we're in radian mode. The pi gives that away. And you got to think of how you could write 5/12 as a sum. And if you think about it, that would be 2/12 plus 3/12. So it would be 2 pi over 12 plus 3 pi over 12. And they don't sound like great angles until you reduce them. If you think about 2/12 is pi over 6 and 3/12 is pi over 4. So really you're doing the cosine of pi over 6 pi over 4. Now what you need is the sum identity for cosine, which says cosine of a plus b would be cosine of a, cosine of b, minus sine of a times sine of b. And again, all these identities are on page 287 of your textbook. They're in a box on the page. And the proofs for those identities are there. I don't really care if you know how they proved it, but you could, if you feel like checking that out, you can as well. So when I'm doing cosine of 5 pi over 12, I have cosine of pi over 6 plus pi over 4. And when you break that up, again, it goes cosine, cosine, sine, sine, change the sign in the middle. So I would have cosine pi over 6 times cosine pi over 4 minus sine of pi over 6 times the sine of pi over 4. And if I simplify all those using what I know about trigonometry, the cosine of pi over 6 is root 3 over 2. The cosine of pi over 4 is root 2 over 2. The sine of pi over 6 is a half. The sine of pi over 4 is root 2 over 2. And when I multiply those two fractions out, I get the first one, I get root 6 over 4. And the second fraction, when I take 1/2 times root 2 over 2, I get root 2 over 4, and I get a common denominator, which is always going to happen in these type problems. I'm going to get root 6 minus root 2, that whole thing over 4. That's a hideous answer, but guess what? As you move into higher math, those are the correct answers. I'm going to stop it.